So tonight's talk is by Michael Lawrence, who is the founder of technology startup Bloqwork. He's got over 30 years experience in the construction industry. And Michael's also a listed arbitrator with DIAC. Tonight, he's going to talk about blockchain and why we should use blockchain technology in construction, which I'm sure will be a very interesting topic. So I'll now hand you over to Michael for his presentation. Thank you.
Thank you very much, Declan. Just to show that we really are live, I must apologise if my dogs join in the presentation. First of all, a little bit about myself. As I'm a co-founder of a project management company called Insight, and as Declan mentioned, they're the founder of technology startup Bloqwork. Over 30 years in construction, chartered civil engineer, chartered builder, and a qualified arbitrator. I became interested in blockchain technology actually through disputes and claims. I went along to a presentation at one of the legal presentations where they were talking about the challenges of trying to record information on projects and make sure that that eventually finds its way into the evidence. So I did a short course in Oxford Blockchain Strategy Certificate to learn more about it and the business side of it, and decided to try get the startup going to apply the use of blockchain technology. So what we're trying to do actually is to produce a web-based construction platform using blockchain technology to deliver a secure and trusted construction management solution. The idea is to manage all the day-to-day construction data, and through that we would eventually be able to build on top of that various solutions, which I'll talk about a bit later, about what blockchain can add to the management of data on construction projects. So I'm going to take you through a little bit about how blockchain works, and looking particularly at Bitcoin is the one that everybody seems to know about. Everybody's heard about Bitcoin, but in fact, as you probably know, Bitcoin is not blockchain. Bitcoin is the product, if you like, is what it's used, what the blockchain technology happens to be used for, this cryptocurrency, and since then many other cryptocurrencies, but they're not the same thing. You can actually use blockchain technology for lots of other things. And I've got a quote there from one of the professors on the course that I went on, and you can read it there, but he's one of the many people, he's written books and so on, that can see that this type of technology could have enormous ramifications and opportunities. So when we look at the development of the internet, unfortunately, I'm one that's old enough to remember Web 1 and Netscape and Yahoo and the first versions of Internet Explorer, and the annoying buzz on the dial-up modem. So in those days, it was pretty much, the internet was pretty much used for sending messages backwards and forwards, email, and then the first web browsers started to come in. Now, with Web 2, that's generally set as where you could not only read but you could write, and the rise of the Facebooks and the Instagrams and the social networks and LinkedIn and so on, where you're actually platforms and you're reading and writing stuff to the internet and blogs and so on. And Web 3 is the name that's very often given to the use of this types of technology. And I'll just, you may hear people talk about distributed ledger technology, and you may hear people talk about blockchain. Like all technologies, and particularly new technologies, there's all sorts of buzzwords going around, and you've all heard about NFTs and all sorts of other things. But in a nutshell, the very first technology that was that was used, which I'll describe a bit later on, which was used for Bitcoin, and then modified for other types of blockchain technology, is a form of distributed ledger technology. And since then, there are other forms of distributed ledger technology which achieve the same as blockchain, but they're not blocks of data chained together, which is, as you can imagine, that's where the name has come from. So there are other types of technologies coming up, and there are adaptations on blockchain technology and hybrids and all sorts of other things. So all of these things together are called distributed ledger technology. And they all have in common the fact that you're working on a network of computers. The data is not held in any one place, and that presents certain advantages in terms of how data is managed. So diving into now blockchain, and taking you through a little bit how the blockchain works for Bitcoin and other adaptations of it as it goes through, and some of the characteristics. Now, when people ask me, well, what is blockchain? What is it? It's really not that complex in terms of what it does. And I like to describe it as like your Excel spreadsheet or like your normal data source, but in a cloud. If you can imagine that you have, everybody has a spreadsheet on their computers which records certain transactions, and through the technology, once you update your spreadsheet, then it propagates throughout the network and updates everybody else's spreadsheet. That's kind of a neat way of thinking about how it operates, which means that you're not relying on a single source, a single computer. You're not if a data center goes down, if your server goes down, the data simply gets repopulated back into your spreadsheet. So that is what essentially you're achieving. And it's useful to think of that when you think about the uses of blockchain technology, because the bottom line is it is a good technology. It's fantastic, does a lot of things, but it's not the be all and end all. And quite simply, sometimes if a centralized database can achieve the same thing, then there isn't the need to go into this complex type of arrangement. But and with Bitcoin, obviously, what Bitcoin is replacing is a central bank which maintains a ledger in and out of transactions. Normally, that would go through a third party, through a bank, through somebody who maintains that ledger. And the beauty of Bitcoin when it comes to and other cryptocurrencies is you're not reliant on that third person to doing that. You're reliant on the technology behind this automatic propagation of databases around all the computers in a node. So it provides real-time information. Because of the way it's set up, it's trusted, it's fraud-proof. The frauds which have happened have tended to be the frauds that which would happen anyway, in terms of stealing passwords and getting into various wallets and so on, just using the same techniques as you would normally. It's not actually a failure of the technology itself. It's transparent. although you can also make it secure, you can also make it less transparent. And you can think a little bit about internets and intranets and the way they operate at the moment, and the way that sometimes your organization wants to use a public internet, and sometimes it wants to use an intranet within the organization. And a blockchain can be private, or it can be a public. So it's the protocol for the blockchain, and for the very first blockchains, was back in the days of the last financial crisis in 2008, when it started. And the clever thing was not actually the blockchain protocol which hosted Bitcoin in itself. It was the marrying together of different types of technology which had been around for a number of years, and the marrying together of cryptography, game theory, and peer-to-peer networks, and putting those together. So the genius of Satoshi, who was a mystical guy who nobody seems to know who he is, who actually started the Bitcoin network with that blockchain. The genius was in him marrying together all of these technologies. So first of all, I want to talk about something called hash functions, because this is a key to the way that the way that transactions and information is kept secure on a blockchain. And a hash function is an algorithm on the computer which creates any data into a fixed length number. The numbers is to the base of 16 rather than to the base of 10 or 2 or whatever, which is why you get these ABCs in there as well, because you have to add those extra digits in there to get to the 16 base number. So the way to think of this is like a digital fingerprint. So any data, whether it be a word or whether it be a video or a picture, can be converted into a fixed length number through an algorithm by what they call hashing. And you can see an example there where I've written Bloqwork 4 different ways, and it creates got a completely different hash function. These hash functions need to have a certain characteristics. They need to be non-reversible. So the idea is that once you get the number, you cannot go back to the data. You can't recreate the data. In the same way that if you get somebody's fingerprint, you can't recreate the person. It's a one-way algorithm, but very easy to check. So given exactly the same data, you can perform the same hash function and see if the number matches. And this essentially is the way that passwords work on computers, so through this type of technology. So if, for example, I have this picture has created the function at the bottom. And then if I change the picture, that creates that function there. Now, you probably, unless you're very eagle-eyed, it's very difficult to spot the change in the picture, but the number has changed completely. And the only thing I've done is to either add or delete that little cloud which is within that blue circle, which you can just about make out in the middle. So if you delete it, it gives you that function. And if the cloud is there, it gives you that function. So that shows the power of a digital hash function for any amount of data that you feed into it. It gives you a completely different number. So moving on, this is what actually a blockchain looks like. It's blocks of data which are chained together through the hash function. So if I take you sort of, description down, there's a block number there. There's a number of transactions. which in this case represent transactions in cryptocurrency. But within that, rather than transactions, you could put any data in there, any data which you wanted the blockchain to manage. And when you think about what an NFT is, what an NFT is effectively is a digital representation of the certificate or the data which is linked to that block. And it's so the information that goes in there is that. Underneath you see something called metadata. Now the metadata, the first part of the metadata is the previous hash. And what happens is that when you have a block and you have all the information in there, then that goes through the function which I've just mentioned and throws out a hash number, which you can see at the bottom in green. And where you can see on block number 5 at the bottom, you've got a hash number, that green number 0533E9, etc. That represents the hash of all that data in that block. And then when you go to block 6 and you look at the previous hash, you can see that that previous hash number matches the hash of block number 5. And that is essentially how the blocks are linked together, which means that when you have all of these blocks chained together through this hash, you cannot go in and change the transactions in block number 5, because if you do that, you change the hash function in green at the bottom, which means that it won't match what's in the next one. So the only way you can change something in block number 5 is when you've got all the other blocks in place, would be to change from number 5 onwards. And you can imagine that as the chain is constantly updating itself, this is an impossible exercise to try and do, because in real time it's always updating itself. So that's the way that data on a blockchain is kept, what they call immutable, which means that you can't change it. You cannot change the data once it's put on there. If you make a mistake, then you have to put another block on there that says I made a mistake on the previous one, but you can't change the previous one. You would have to put some sort of correction into further blocks. You'll find also that within the block that underneath the timestamp of the block, there's something there called junk. And this or the nonce, this produces what they call the nonce, which is where this all this mining comes in that you hear about on the Bitcoin network. Because when a block is created, you can imagine on a network, it can be created on multiple computers at the same time. And since you can only ever have one chain which represents the truth of all the transactions, how do you determine when, say, 5 different nodes all solve the block at the same time, which one goes into the network? So you have this concept in the Bitcoin network, and in fact still on the Ethereum network as well at the moment, of mining. And what mining is putting in a figure in junk, writing a random figure in there to try and get a fixed number of zeros for your hash. So what you're trying to do is, by trial and error, in this particular case being a very simple representation of a blockchain, which you can find at that link there, all the hashes you'll notice start with a 0 for the block. In reality, with a Bitcoin network, it has to start with 4 or 5 zeros. I'm not sure how many zeros you have to get up to, but currently on the network. But the more zeros you have to start with, then the more difficult it is to find that number, that random number, which generates a particular hash, which, as I say, in this case starts with 1 0. But if you want to make it start with 2 zeros, 3 zeros, 4 zeros, and that's the way the Bitcoin network works, is that as time goes on, there's more and more zeros which are required for the hash, which makes it more and more difficult, more and more computations required to guess that number. And this is where you hear about banks of computers trying to solve this mathematical problem. And it's all about, like I say, it's all about trying to make sure that there is only one block or one person which finds the block which makes the blockchain. What actually happens in reality then is that in any moment of time, if you can imagine sort of a tree growing, you have one trunk growing up the middle, and you have various branches off, because there are a period of time while the transaction is happening, where you might have 2 or 3 different versions of where the chain is going. Eventually, one person solves it, or one organization solves it. His is verified as the true one. The other 2 and the branches, they come away and they go back in for resolving again, and eventually they will come on. So as you get further and further down the trunk of the tree, you're only getting one version of the truth. So it's only when you get to the last transactions where you've got various potential different solutions for a short period of time until it settles down. Another key thing to understand about blockchain technology is how people identify themselves and transactions on the network. And this is done again through cryptography, where you have 3 types of keys. You have a private key, and that is generated in your wallet when you're doing a Bitcoin or crypto, some sort of transaction. But like I say, this could apply to anything. So it could apply to it's really just a way to identify an individual. So his private key is created for him automatically by what they call a wallet, which automatically authenticates him as the buyer or the seller, or the person that's sending the information, if you like. And at the same time, it generates something called a public key, okay, automatically from the private key. And it generates an address where the transaction is actually recorded as, this person buys and sells, or this is what is happening on the blockchain, the information on the blockchain. So, and the main thing here, the important thing is you can't generate a public key from the address, and you can't generate the private key from the public key. It's a one-way transaction, which generates the security and ensures that a certain wallet, or which may, may be anonymous, maybe it's not actually got somebody's name on it, but it is has an address. A private key address, a public key address, and then the address where the transaction takes place. Now we come on to something called smart contracts, and this is a development of the very first Bitcoin networks, which were developed in for crypto transactions and so on, where people realized we don't have to just put the transactions of this person buys and this person sells and this is how much he's got left. We can in fact put a computer a program on there which will carry out certain functions on the basis of, if this happens, then do this. This was really the development of the Ethereum network. And the genius with the Ethereum network, because now you get not simply on a blockchain network something buying and selling, but you can really then create functions on there. For example, if this person appears for this number of hours, then he will get paid this amount of money. So if these number of hours have gone in, then that, providing that's to the right quality, then this payment takes place. So these types of things come in through smart contracts, which is a bit of a misnomer. They're not really smart. They're not really contracts either in as we know them in construction. It's a set of instructions which people say is more like a vending machine, if you like. It's more like, you put the money in and the Coca-Cola comes out. However, in the context of construction, there are people looking at the development of smart contracts through something they call Ricardian contracts, where there are people with the ambition to actually put contracts from construction onto as smart contracts onto a blockchain, and through a set of instructions can occur. So that's taking you through through blockchain technology. I'm going to just briefly cover some of the use cases, and you will have heard through the early 2000s, and since 2008 there was a hyper activity, and in fact just very recently you're probably also well aware that certainly in terms of Bitcoin and cryptocurrencies, there's been a huge crash in the value of them. Now, that, to my mind, will actually be a positive thing. It sort of takes you through the trough of disillusionment, and there will be people that are in there just for making money on cryptocurrencies, and there are also a lot of people who are putting real use cases together. So I'd like to think that we're sort of onto the plateau of productivity now, that we're starting to slowly develop real use cases, and some of them have been around for a while. The Mearsk one was one of the early ones. Mearsk have developed a blockchain network for the movement of containers and for recording all of the documentation. And one of the very early use cases of blockchain technology away from cryptocurrency has been through logistics and through tracing transactions. So typically, as you can see there, there's 200 transactions which happen when a container, you can imagine, has to go from a factory through the port, and from one port to another through customs clearance, and there are all these different stages. And all of these people, they all have their own databases. They all, are happy to, to have some sort of collaboration. They would probably all like the transactions to move through their own central database, but then Mearsk and people like that do not want to put all of their transactions through, say, Amsterdam port or Singapore or whatever. So all of these various sources of data from suppliers and shippers and customs people, they all need to talk to each other, and they all need to record the transactions in a trusted way. And the Mearsk, originally developed by Mearsk, but now actually used by many other shipping companies, is a way that happens. In a similar fashion, where Walmart had a particular problem when stuff turned up on the shelves, and for one reason or another was not up to scratch in terms of the product quality or the value. And so you can imagine these big organizations, they need to trace back, they need to find out where, the example was given, where this mango came from, which farm in South America. And that could take days. to try and trace it back through the suppliers, which, as you can see now, they've vastly accelerated it through the use of blockchain technology. And a similar use case where different people are sharing databases and tracking the movement of goods through the supply chain. But without doubt, the greatest success at the moment has been the development of blockchain technology and distributed ledger technology for finance, where it's grown beyond cryptocurrency. It's now moved into all sorts of digital assets and authentication for typically when when you need to reveal your identity to a bank and verify who you are. That authentication is a typical ecosystem which is ripe for blockchain technology, where various different banks can have their own databases, but of course, no one bank wants to rely on another bank for identifying individuals. They need some sort of way that they can share information across different databases. So where does this all take us to in construction? And when through the use cases, there's really sort of three types of use. One is the transfer of value, so through smart contracts and so on. So that is the ability to be able to pay somebody or to, for example, record tokens which represent the value of bonds, or, for example. But it's all about the transfer of value. So what you can't do at the moment with the Web 2 or on the database, you can only do with this type of technology is pay somebody or transfer something. And in construction, that's not necessarily, we're talking just about monetary value. It could be about KPIs for management of safety. It could be about carbon credits for the for a project in terms of its eco value and the impact on the on the environment. The second use case is through provenance, and the types of examples I've mentioned, which again in supply chain management in construction, is the material that's arriving on site, is it the right quality? Has it gone through all its various checks? And when you're talking about, for example, assembled goods, you're talking about a fire door. It's not just a fire door which has to comply with whether it's 1 hour, 2 hours. It's also the ironmongery. It's also the frame and everything that goes around with it. And it all has to be certified. It all has to perform as one. So all of the different components coming together, and then notarization in project management, just simply the recording of data, the immutable record, which again serves a strong use in construction. So the challenges we face in construction with this type of technology, as with all types of technology, I don't think it's the least digitalized ever. I think probably they talk about agriculture and farming and then construction. So, but at least it's something which is changing, but we are a very conservative industry. We're very, very heavily fragmented, which actually creates a huge advantage for blockchain technology to bring all these fragments together. But unfortunately, we don't spend too much on research and development. And the other problem that the use of blockchain technology faces in construction is that when you talk about these types of technologies, then it's immediately associated with Bitcoin, and that brings a whole sort of subculture, and people, for example, in the current climate would say, well, I'd want to pay somebody in Bitcoin. it's a third of the value it was 3 months ago. And this type of association, which is completely, when we talk about paying people using this technology, we're not talking about paying people with cryptocurrency. What we're talking about is using the technology to tokenize the construction project, which means that through finance organizations, you're able to create a token which is in the real world as fixed to fiat currency, into real money, and then you're able to use that token and use the way the blockchain technology works to pass on that token or parts of it, which can then be transferred back to money again without any loss of value through it's not, as I say, a cryptocurrency type of transaction that you're talking about. So the big problem, in trying to instigate this technology is you need on a project all people to buy in. You need the project data to be on the blockchain, because if you're using this technology to replace a normal project management information system, then you're achieving a little bit of an advantage, but not a great deal, because if you use your Aconex or your Procore or whatever, that is centrally held on a database, and there are certain advantages. For example, the fact that on a blockchain the information cannot be deleted. Now, of course, suppliers of these types of PMIS will say, well, it can't be deleted in our servers either, but technically it can. But we're not really looking to replace these systems. We're looking to link these systems together through blockchain technology. So linking together PMIS systems, if somebody uses a PMIS, if somebody else uses their local server, and there are other ways now which people save their information on there. We're looking to link all of these together. Currently, people are using either cloud or local servers or a combination of the two, which means it's not immutable. The information can be erased, and it's not time-stamped. It's not, when you look at it on a project basis, fully searchable. I mean, within an organization, they can be using something centrally for their data, which they can search. But when you come at a project level, you cannot search it. We can host smart contracts, which I mentioned to you, which then provides the ability to transfer data. And then in the future, as the amount of data grows in construction and we get more and more data through the Internet of Things, then this can manage the data as well. So the typical things which people are looking at, there are people looking at managing BIM data through blockchain technology. We're not looking to replace the BIM model or replace anything there, but perhaps a way to find out who added what to the BIM model when, and also looking potentially then at rewards and paying people in accordance to how they add to the BIM model. There's papers written on that. Automating payments through the supply chain, which is one of the uses I've mentioned. But again, as I say, it relies on people within the supply chain on a project all using this technology. Managing and recording carbon inputs into projects, which is one potential use. As I mentioned, it's not just monetary data, but it could also be other types of data. I came into this through the interest in avoiding and resolving disputes, and for me, if I was able to go onto a project and be able to have access to all the transactions which happened on a project through, from supplier to subcontractor to main contractor to employer, and look at it from all angles. I think that would just the existence of that information would avoid many disputes, and it would resolve the disputes that do arise relatively quickly. The golden thread of project data, which is the buzzword in the UK now, after the Grenfell fire, of about how data gets transferred through a project. You would have the ability, if you use this on a project from beginning to end, right the way through to the operation of the asset, to have access and retain all of that information. So this is the promise of the use of this technology. I think it's important to put things in context. The industry is evolving. It is updating itself slowly. I have an interest in all sorts of technology, and but blockchain technology is a part of the solution. You hear people talk about cloud-based, common data environments. People talk about the BIM model. This is not a replacement for any of those. It's the way I see it, as something which has the ability to tie all of this together in the future with projects, and be a part of the solution for industry for construction. So that's I've come to the end of my slides there now. So I just wondered if we had any questions that anybody would want to ask, and I can't see the questions, I'm afraid, so I'll have to rely on you, Declan, to see if we've got any.
Yeah, that's okay. Thank you very much, Michael, for that very interesting talk. I'll just ask if anyone has any questions. You can just put them into the Q&A chat box.
That's one come up.
Okay. So yeah, one question. Do you think the industry is ready to embrace advancements in technology such as blockchain and artificial intelligence?
Yeah, I mean, when I talk to organizations about the use of this type of technology, I find that they are in one of two camps. They are either sort of not interested or not looking at this at all, or they are into everything, and they're into they want to try everything. There doesn't seem to be any sort of middle ground. One of the things I think it's important to realize when you look at the future of this technology and all technology in construction in general, and particularly when you talk about AI, is where is the construction industry heading? And when you talk about AI, where AI can eventually take us, and you talk about ultimately human level artificial intelligence replacing the human, then you start to then question many of the activities within construction. And I'm talking about project managers, I'm talking about quantity surveyors and general contractors, and people who within the construction industry are performing a process of managing different inputs and outputs in construction. Because that's the first thing which I can imagine AI and this type of technology replacing. Where it's going to be more sticky and more difficult and take longer is at the creative end. You know, the design and the front end of that thing. So I ultimately see construction moving when you talk about, which entity or organization is going to eventually control construction, then it has to be, ultimately, it's going to be people who have the control over the design and the front end of construction, because the back end can be automated, robots, AI, etc.
Okay, thank you. Another question: which type of platform base do you think would be suitable for implementing smart contracts for project management work?
It would have to be. There is Ethereum, but Ethereum, one of the problems with Ethereum is it's quite expensive. There's multiple blockchains out there. We were originally looking at something called IBM Hyperledger Fabric. Hyperledger Fabric is created by IBM, and in fact, there is one organization in the States who's called DigiBuild that's creating a blockchain technology, but it's, in their particular case, it's a substitute for a PMIS, so it's just, if you like, an ACONX built on the blockchain. The problem with pure permissioned blockchains like Hyperledger Fabric is when you come to make payments, because when you come to make payments, you need something very robust, which will stand up to the banks, and the banks will be happy to use. So you then look at other types of blockchain technology out there, but we haven't settled on what the best solution is yet. We're looking at different ones, but it has to be something, as I say, that the banks will do.
Okay, thank you. Another question here from Sama. Just interesting that the topic is a bit above our heads to understand at first, based on one talk like this, and just a comment that maybe embedded carbon calculation or data kept on the blockchain might be easier for the construction industry to follow, shall we say?
Yeah, I do agree with that, in that when you look at where it could eventually end up, and if you're putting all the information on there, and we ourselves are looking at stepping steps to get there, because the most difficult one to crack, I think, is payments, because understandably, the way the industry is structured at the moment, nobody wants to pay anybody, and when you talk to contractors in terms of saying, well, the last thing I want is a automatic contract where I pay my subcontractors the minute I get paid from my employer. I don't want that. So whereas the banks and the government would say, well, it will ultimately be good for the industry, and I think that's where things will eventually end up. But perhaps one of the mistakes I made was seeing that as a very good use case, which I think it is, but through the way that the industry operates, it's very difficult to implement that. And as your colleague that says there, perhaps carbon credits is an easier one to start with.
Okay, thank you. Another question from Ahmed. Blockchain seems more useful for contracting companies rather than design and engineering companies. Would you agree?
Except, as I say, the potential use of managing the BIM model is one thing which has been mentioned. But yes, I mean, I think I myself have been focusing more on the delivery end of the use of the technology. there's an argument to say, well, you have consultants, you have sub-consultants, you have the BIM model to manage, and you have, a number of, you have a lead consultant managing a number of consultants. But perhaps because it's a relatively small number of participants, they can perhaps more efficiently do that through a central database, which they all agree to share, rather than go to the expense of a blockchain type of solution. So yeah, I think there's some merit in that.
Okay, and the next question, is it possible to merge and use different platforms?
There's a race on at the moment to develop that, and it's interesting. The people that follow all of these technologies very closely, because the short answer at the moment is no. If you're using one particular blockchain, of which there are probably hundreds by now, of different people, all have their different edge as to why their particular blockchain is the best. But you don't have a blockchain of blockchains. You don't have a way of using those. And there's 3 or 4 different projects which are racing to solve this problem. And they obviously realize that the one that cracks it is going to have enormous benefit, because they are going to effectively have the blockchain of blockchains, and you'll be able to do things on different blockchains, and transactions will be able to move across from one blockchain to another automatically. And when you delve into it, there are people trying to crack that, but short answer at the moment is no.
Okay, thank you. And the next question, is there any data available for how much it would be commercially effective to shift to blockchain technology?
I'm not aware. The issue at the moment is that there's very few of us actually in the field trying to implement it, and we need to get a project off the ground. We need to get a control project where we can do that. As I say, DigiBuild are trying to do it, but they're very much US centric, and I'm not sure yet whether they've got data which do it. But there are people which talk about issues with data and losses in data in general, and I suppose if you look at those types of model, then there are some considerable commercial savings, but nothing specific on blockchain at the moment.
I suppose the time saved for arbitrators and the like is hard to measure.
Yeah. So time going through containers in the back of a construction site, finding programs and data.
Yes.
Yeah.
Another question, is there any other technology available other than blockchain to implement smart contracts, or is it like only blockchain that could support smart contracts?
Yeah, it is really only blockchain technology which is supporting smart contracts at the moment. There are other distributed ledgers technologies, but they are more geared towards the Internet of Things and smart cities and driverless cars, where you have a vast amount of very small amounts of data which needs to be shared. So typically the driverless car, which is driving through a city and needs to communicate with traffic lights and police and all sorts of other things, has a form of, there's forms of distributed ledger technology, but it's not blockchain, because blockchain doesn't work in that context. So that's the main other form of distributed ledger technology which is being researched at the moment.
Okay, thank you. And might be our last question. We've had a few, which is great. Can you give a few service providers who are currently working on Hyperledger Fabric for a complete smart contract implementation on construction process?
I can, yeah, I mean, I have not got the information on, but the best thing might be if they put their information on the, you know, in the chat in terms of an email. There is a provider which I'm aware of that does a sort of a white box, you know, solution for specifically for construction. I don't know. I can't say recommend them, or I can't say they're bad either. I don't know, but I do know of somebody that's doing that. Yeah, yeah.
Okay, if that person can just give their contact details to us, we'll pass it on to Michael. Another question has come in. Why do you think the industry is so far behind in adoption of blockchain technology, technological advancements in general? Is it a lack of understanding or a lack of financial incentive?
I think there's two things. First of all, very narrow margins in terms of the development, but I think the main reason is the vast number of very small companies which dominate construction. When you look at the average number of employees working in construction companies, even in sophisticated markets like the US, you know, it's dominated by companies of 5-10 people. You know, of course, you know, we all know about the big names and the big names in this industry, but when you look at number of employees in those big companies compared to the number of people that work in the industry, it's dominated by very small companies, construction, even in the sophisticated markets. And I think really, until that changes, when you compare us to, say, you know, the automobile industry, you know, the big car companies have a huge number of people within them, and then they control a number of, you know, lots of smaller suppliers. But that's the main reason, I think.
Okay, thank you. So I think that's it for the questions. So Michael, thank you very, very much for giving the talk. It was very interesting, and you can tell by the questions that it was the people online found it good as well. So just a reminder to everyone. Yeah, thank you. Just a reminder to everyone that the talk will be saved on the regional groups YouTube channel along with all our other talks. So what we'll do now, I'll just pass you over